5, the last topic in Unit 1, so we'll take our first examination next week. We're going to wrap up Topic 5 on Thursday. So, design experiments. Topic 5 is on experiments, where Topic 4 was on designing observational studies. Design experiments, an investigator assigns the experimental units to their treatments and measures the effect on a response variable. With random allocation to the experimental groups, the effect of any confounding groups should be spread equally among the groups. So randomization helps prevent effects from unanticipated variables. This allows a conclusion of cause and effect relationship between manipulated factors and the response variables. So, our definition of an experiment and how it differs from an observational study. An experiment relies on volunteers. Right? For an observational study, we're going to randomly select from the population. Okay? With an observational study, we want our sample to be representative of the population of interest. Experiments, we can't do that. Right? We can't force a random sample from our population to take this experimental drug that might have all your hair fall out. Right? We need to rely on volunteers. And oftentimes volunteers are paid in experiments. Right? This makes it difficult to extrapolate the results of an experiment to the population as a whole. Our goal for an experiment is not to extend this to the entire population, but instead to establish a cause and effect relationship between an explanatory and a response variable. The key to doing this is we want our experimental groups to be as alike as possible in regards to all variables known and unknown, and we want to change simply one thing. Now, one thing is the treatment. So when we're talking about our strength shoes group, right, we randomly assign those into 2 separate groups, and then we change one thing. One of those groups were the strength shoes, and therefore, since those groups were as alike as possible in every way, we can establish that the strength shoes caused the increase in jumping ability. If we do have variables that we know are going to affect our outcome of our experiment, we can control for those by using blocking. We found that in the long run, gender and height, right, were balanced out over time, and that our histogram centered around 0. Right? But what if we did get one of those that was on one side or the other? Say we had 6 males in one group and then only 2 in the other. But so are those groups as alike as possible? No. We can control for that by first separating the men and the women, and then randomly assigning an equal number of men and an equal number of women to each group, so that variable is balanced out. Keep in mind, as stated before, our goal for experimental design, our groups, experimental groups, are as alike as possible. So whatever we can do to ensure that, we're going to go ahead and do that. We still want to go ahead and have that idea of random assignment too. Random assignment helps smooth out the effects of the person administering the experiment. And we'll have various methods to go ahead and make sure the people administering the experiment not have an effect on the subjects and their responses to whatever treatment they have. Oftentimes, we are going to want to do an experimental diagram. So here's an example of one. So muscle strength compared. We have 43 volunteers. We randomly assign them into 3 weightlifting groups: heavy load, moderate load, and control group. And then the muscle strength is compared. Right? The key is we need to make specific notation as to where the random assignment occurs. Let's take for an example a step further. We had our 12 volunteers for our strength shoes. Right? We had our strength shoe group. And then we had our ordinary shoe group. And when possible, I'm going to put the number of experimental units in both of those. Or subjects when we're talking about people. So people don't necessarily like being called experimental units, so we call them subjects when they're people, experimental units when they're anything else. Okay? And then at the end, right, we want to compare the mean jump height between the two groups. We need to make note where random assignment occurs, and we can just put it vertically right here. So random assignment goes right there. Random assignment. So we need to start with our volunteers. Clearly note where random assignment occurs. They are randomly assigned into these two groups, and then our response variable at the end. Quick diagram, an experimental diagram. And when we're designing an experiment, this suffices, even on the AP test, as a complete explanation of how you would design an experiment.